Hello, everyone, and welcome to this new webinar about how to teach ROS to your interns in a fast way. Let me introduce you myself first. So my name is Ricardo Tellez. I am the CEO of the company Deconstruct, and at Deconstruct, what we do is to build tools for making people learn and develop programs for ROS in an efficient way. And that is why I'm going to talk to you today about how to teach ROS in an efficient way for your lab interns specifically. Okay, so just before I start with everything, let me just give you a detail that if you stay with me until the end, I will provide you with some instructions to get the slides and a white paper with additional information of the subjects that we are dealing today here. And I will provide these instructions at the end of the webinar. So please stay with me. And what are the topics that we are going to deal with today? Not ROS topics, but presentation topics. And if we do a ROS topic pop of that, that will mean typical training and setup. So I'm going to show you what is a typical training and setup of the labs where the interns, they appear. Then I'm going to show you the situation that the interns are facing when they get into this training. And so then later I will show you how you can make them learn ROS fast. And we'll conclude with a short demo of a system that already works with this theory of how to learn fast. And we'll go to the question section. And let's go then. So first thing, what is the typical training of ROS? So many of you have already suffered this way of learning ROS, I'm pretty sure. And then the thing is that basically consists of those two steps. So you have a computer there, then hey, install ROS and Gazebo, and go to the wiki tutorials of ROS Wiki, and then do whatever you can. And that's great. And maybe the tutorials, you will be able to see some numbers that change from one place to another. And if you are lucky, also a turtle that moves around. Okay, great. So what can I say about that? Well, the thing is that the method works. I can tell you because I am here. I have learned using this method. And many of you that are attending today, I'm sure that you have also learned using this method. And the other thing that I can say is that it's completely inefficient. So this method is not efficient at all. And if you don't care about efficiency, like bad scientists or European projects or politicians, civil servants, okay, that's okay. But then this is not your webinar. So I think that you cannot get anything from here. In this webinar, we are going to learn how to be efficient, how to be the best and the strongest lab in the world. And for that, we have to be efficient because we have to compete with others. So in case that you don't care about efficiency, then it's done for you. So you can leave. I will wait some seconds for people to leave if they are not interested in efficiency. Okay, so I'm leaving. I can see the numbers. Great. So we have already the people that is interested. Great. So now let's go and see the typical lab setup. And this is the lab that we provide to our interns. And basically what it consists of. So basically it consists of three things. First, there is a set of ROS packages that have been done previously by somebody else, by some other interns, by the teachers, the researchers, and they are there in a hard disk, in a Git, and they are there. Then there is probably a robot to work with in the lab, and maybe this robot has or has not a simulation. Basically, it's a robot that you have to program. And then there are some computers around to work with. Great. So that's the setup. Then, what is the challenge that the interns are facing against this setup? Well, let me show you. The interns, it's very likely that they don't have any knowledge of Linux or C++ or Python. And those are basic skills for learning ROS and using ROS, of course. Most of them, they don't have any knowledge of ROS. Of course, they have absolutely no knowledge of your packages because they are very specific for your system. And they probably don't have any knowledge of a robot and don't knowledge, of course, of the robot simulation. So how can you imagine how challenging this is for the intern, that he has to learn? And what he has to learn in order to solve all these problems is, first, he has to be able to manage Linux shell, C++, or Python in order to work with ROS. Okay, so I can handle that. Yeah, okay, I can do it. Okay, what else? Well, you have to learn the ROS basics. What is a node? What is a topic? The parameters, the ROS core, the RBs, etc. Okay, so far so good. Okay, ROSDF. ROSDF is fundamental for ROS. Yes, okay, so that I had to learn also. And what about ROS URDF? How to build your robots, how the structures of your different robots, of course, very important. And to debug, of course, are going to build programs in ROS, and then you will have errors for sure, so you will have to debug. Then once you reach the point of ROS debugging, we start learning some more useful things in ROS, like how to make the robot navigate, how to perceive things, and of course, how to manipulate. That depends. All those subjects depends on your lab, what is focused, but those are the three main subjects that they may learn in order to make a robot useful in research. Finally, they have to learn to program your robot. Yes, so imagine how many things those poor interns have to learn, and that's a lot for them. they just see this and it's amazing. So that is why the enthusiasm in when the days where they are there and they have to learn by their own with very little support. So it's a little bit frustrating for them. That makes the speed of learning even slower. Okay, so see, if that is the situation, how can we learn? How can we make them learn basically ROS fast? Okay, so we are going to propose here a method that is based on some of the books that you can see here on the screen, and other books also that they describe basically the same thing. But the main point of this method are the following. First, we have to deconstruct ROS for the students. What does it mean, deconstructing ROS? It means that somebody that has the full knowledge of ROS then see what are the important parts of ROS, what are the most useful parts to learn, what are the interconnections in between the different parts of ROS. Okay, so that's the constructing a subject, finding the internal parts that compose this subject and the relations between them. Then the next thing we do is to apply the 2080. We identify the 20% of the subjects that will make the 80% of the progress. Yes, sorry, they don't have to learn how to install ROS. It's not important. They don't have to learn how to use the C++ at the beginning of their knowledge. That's not the subject that is going to do the most advanced by learning just a little bit. So what we do is we identify these 20%, and then we remove the rest. We just remove, okay, but they need to know that. Okay, they need to know, but maybe in the future, when they have the package of things that produce the results the fastest. And then equipped with this knowledge, they can try to learn the rest, even at the fastest pace, because they will have their head, it will have the knowledge, the required knowledge to understand those other subjects faster. But by now, we cannot try to provide this knowledge at once to the student. So we identify this 20% and remove the rest. Forget about the rest. Then, of course, we make them practice. Practice is the key. It's the key. So even if you have all those 20% identified that are the most important ones, just by reading, just by seeing and copy-pasting things, this is not going to work. The learning is going to be very slow. If they have to learn fast, they have to practice a lot. No copy-paste allowed. No, because copy-paste is just, okay, yes, I see that if I copy this and here, it works. But they don't try to put into practice what they have learned. So that's important practice. And also, of course, take exams, and exercises is the same as practice. But exams are very important because it's the point where they get stress about the subject, and that's what makes the information to be fixed into the brain. So that's a method that we propose in order to make the students, the interns, to learn faster, ROS. And about the deconstruction of ROS, this is the deconstruction that we have done, and the one that we propose to you, that you use for teaching your interns. You will have in the slides this, so you don't have to worry about this information. So I'm just going to comment on it. Then, sorry. So first, we have some preconditions. And those preconditions, at the beginning of our company, we didn't care about that because we assumed that people was with skills of at least of Python and Linux shell. But I can tell you that by practice that this is not true. It doesn't work. There are so many students, they do come to our place to learn ROS, and then they don't know Python. They don't know how to get into a directory. So we have set this as preconditions. I will show you later how you can make the students to learn this automatically without having you to be there for teaching them in a nice way. So then after they have learned Python and Linux shell, then they have to go to the basics of ROS. These are the two subjects that will make the most difference at that point in time. They have to learn the ROS basics. That means what are topics, services, messages, compilation of messages, and everything based on Python, okay? You don't have to teach C++ at this point in time, and everything on ROS that you teach here doesn't have to be based on C++, but in Python. You will reach the point of C++, but it's later. But by now, let's make them understand those concepts in Python. But it's a lot easier to understand. It's a lot faster. Okay, so ROS basics, and then ROS debugging, how to use the tools, the different debugging tools that ROS provides to find errors in the programs. Those two are the basics things, the basic of ROS for us. Then we move to other subjects that are very useful in the day-to-day use of ROS programs, like the full ROS overview of TF, URDF, gazebo, and even ROS control. For us, those are very important subjects that most of us use every day in many different projects, independent of the project being based on navigation or on perception or user interface or whatever. So those are the subjects. So that once they master, they will have a full ROS overview at that point in time. Then it's only at this point where you can try to use C++ and make them learn again ROS basics in C++. That's optional, and actually, if you are in a lab, I don't recommend you to use this because it's very unlikely that your lab requires you to have C++ speed and performance. It's very unlikely. Most of the situations, you are not going to, you just need the system to work. And for that, Python is the best option because it's faster. And for doing prototypes, etc. But in case that you need it, is at that point. At that point in time, those guys will already understand what are the topics and will understand how to make the change from ROS basics topics in Python to ROS in C++. Okay, then at this point in time, also you can try to teach them about ROS navigation, perception, manipulation, depending on what your lab is about, what is doing the research. And finally, of course, you can teach them how to program your robot in ROS. That would be the final application. Great. So now, how can you build this curriculum? How can you have this curriculum for your lab interns? Well, you have three options. First option, you build the curriculum yourself in the simple way or the pro way. I will show you both. Or you buy the curriculum from somebody that already provides and that you trust. Okay, so let's go. No, sorry. Before I show you about the building the curriculum, before that, it is prior to any of those methods, is that the interns, they understand how to use the Linux shell and understand how to program in Python. So I have provided here with 2 free online courses that teach that subject. It's from Code Academy, very nice tutorials. And this will put up to speed in those subjects your interns very fast. Actually, could be also a precondition to get the interns get in, that they do this. So once they get into your lab, they already have done it and already understand those basics. Okay, let's go. Simple way of building the curriculum. The simple way. Remember, we have 3 options. You build the curriculum yourself, simple way, pro way, or you buy the curriculum. Let's go for the building the curriculum in the simple way. So what do you have to do? First, you provide the intern with a computer with ROS already installed. Please don't make them install. Yes, for you it's just a couple of minutes, but for them it takes a long time and a lot of confusion. So just provide the computer with ROS installed. Then you indicate that he must use Python for the ROS learning. And then you make him follow the tutorials of the wiki of ROS in the following order. Remember, this is the building the curriculum the simple way. Okay, so it's a simple solution. So it's 3 points. Provide the intern with a computer, make them use Python, and then make them to use the tutorials in the following order. So this is an order that we have created of the different tutorials that are at the wiki of ROS. And this order is based on what I have explained before. This 2080, of course. So if they follow this order, this is the suggestion that we provide, that the learning experience will be optimal. And it's I have 3 pages, as you can see, of learning tutorials in different orders. You can have this list on the slide, so don't worry about this, about taking screen captures or whatever, or copy, typing, don't worry. So 3 pages, okay? So once you reach this point, it's about the navigation tutorials. Then I haven't put any tutorials in this list about manipulation or perception, because the subjects get a little bit more complex than just putting a tutorial. So at that point in time, they will already learn and understand ROS quite well. So you can let them just go to their own interest or what they feel that they need. Okay, so this is for the creation of the simple way of the tutorial. And the simple way is recommended for labs that have very, very low budget So they don't have to spend, they cannot spend anything at all, but it means anything at all. I mean, you know what I mean. So this is when you don't have any money and you also are very short in time. So you cannot dedicate time to your interns. And then it means, again, I understand that this means that you don't have time because you are doing something more important. So for those, the simple way is the best way that I recommend to go. Then let's go to building the curriculum to the pro way. This is the pro way. It's you will have to build the curriculum, but it's a very professional way of doing it. And of course, again, you have to make them use Python, and then you will have to prepare some gazebo simulations for practice. So you will have to build or download from the internet some gazebo simulations that already work in their computers. So this is very important because it's those simulations, the ones that they must use to understand the concepts of ROS. They are not going to follow anymore in this solution the wiki tutorials because they almost don't rely on simulation, so they just rely on the proof of concept. And this method is to speed the learning. For that, we recommend to use gazebo simulations for any subject of ROS. So we'll have to prepare those simulations. We also recommend to use Python notebooks to write the curriculum. It means that you will have to write what they have to learn based on your experience. And of course, based on the path that we have provided you in the previous slides, in this path. In this path here. So what we propose is that you build a curriculum following this path. This is the construction of ROS. Okay, but this is something that you have to build. It's something that is in your hands. Okay, and then those Python notebooks, what are interesting is that they are based on Python and that they allow the interaction between the lessons that you write in the notebooks with the simulations. So you can create really, really nice learning lessons where the user can see the relation between what is writing there in the notebook and what the robot is performing. This is so rewarding for the student. The student will understand a lot quicker because the reward from what he's doing and what the robot is doing, it's very fast. So they just type something and then the robot does something. No? So this is for the brain is very useful to learn fast. Then, of course, you will have to provide a system for installation on the user's computer or the lab's computer. And I suggest you that you use the ROS Wiki to prepare the curriculum, but adapt this ROS Wiki lessons to your notebooks plus gazebo. Okay, this is for labs with very low budget again, but they have some preparation time and they want to have their interns ready for everything, and they care about them and they want to make them learn fast and very well. Then finally, the third option is to buy the curriculum, of course. And for that, of course, we propose that you use the Robot Ignite Academy. That is a product that our company, The Construct, has built. If you use the Robot Ignite Academy for providing the curriculum to your students, to your interns, you don't have to build anything because everything is prepared. It follows, Robot Ignite Academy follows the same method that I have proposed here. But the only difference is that it's already done for you. So you don't have to you don't have to build. What? You don't have to build. You don't even have to assist because the whole system already has the lessons included in there. And also we have our own assistant system. It's an online mechanism with forums, with live chat, where we can assist the students and provide solutions to their problems. You don't even have to follow if you don't want. but you can follow if you, there is a special screen where to follow. I will show you later. And you don't have even to care about the computer. That's the most interesting part, because many of the students, they come with their laptop, so you don't have to prepare special computers in your lab. If you have them, that's great. Also, you have them, you don't have to care. Oh, does this have Linux? Which version? This graphic card? Whatever? No, doesn't matter. Our system works on the web, so they can have any Mac, can have a Windows machine, they can have an old system as far as they have a modern browser. And of course, we provide courses for all the subjects that we have indicated about ROS basics, TF, ROS control, URDF, etc. And how does it looks like? So it looks like this. I'm going to show you in a couple of minutes. I'm going to show you a live demo, but this basically is how it works. In the computer, you have on the left-hand side, you have the lessons that are extremely practical. So they are not, if you do this, you will get that, and this is a ROS topic, this is a, no. This only is based on exercises that the student has to do and see the results on the simulation that we have on the right-hand side. And the student uses the IDE that is in the middle to build his packages, his programs, and uses the shells that has here beneath to execute the packages, compile the messages, and do whatever in a normal ROS environment they have. And of course, the result of their executions here will have a result in the real robot, in the simulated robot, sorry. So they can see in an instance if they are doing well or they are doing wrong. And well, we have many different courses, apart from the ones that I have shown in the construction path. Apart from that, we have many others, like OpenAI, 3D navigation, autonomous vehicles. Well, you can explore there. And of course, recently we have included specific lessons for programming specific robots. So if you have any of those robots here, like a Tiago from Robotics, a Turtlebot 3 from Robotics, or a Summit XL, we have also from ClearPath, from Shadow Robot. These are specific lessons that teach you how to take the most of those robots. So in this case, you will have the whole path covered for your students. Finally, we have a screen where the lab manager or the person who is in charge of the interns can see the progress of the different interns, how they are doing, if they have done different lessons. He can activate or deactivate the exams, so the student can get, one of the lab interns can do the exam at a certain point in time, etc. Basically, this is what we use here in Barcelona for teaching ROS, for teaching navigation with robots at La Salle University. And this is not only the only university that is using. Around the world, it's been used, this system, for teaching to many people in the University of Valencia, University in Spain, University of Luxembourg, Tokyo University in Japan, Weingarten University in Germany, etc., etc. So we highly recommend this. What is this academy for? It's for labs with low budget. So you don't need a very, very big budget for that. So it's for low budget and labs with very, very limited time. They need to be effective. So this is for labs that want to excel, want to be the first, the number ones. This is the target of this type of curriculum. And now, if you allow me, I'm going to show you a live demonstration of the system of this, how it works. You will have in the white paper a way of doing your own, how you can build your own curriculum. So you will have more details there. In case that you don't want to build it, this is the demo that I'm going to do right now. You can access directly to this system, the Robot Ignite Academy, and get started right now with any web browser. So for this, let me just switch here. Just a second, I'm going to switch to another screen so you can see the platform. And here it is. So if you visit our webpage in ROS Learning, our webpage is www.theconstructsim.com. And here we have some delay for some reason. Let's see what is happening. Looks like the net is not working. This is just the WordPress page. So here it is. And then you log in. Okay, so that's strange for the network. And if you log in, let me just reload it because I think it didn't. So let's see what is happening here. Looks like there is a problem in the network because this is getting very, very slow. Okay, so I'm going to type here my username. Password. And then let's get in. Yeah, for whatever the reason, it's loading kind of fonts from Google. I don't know. Yeah. So, see. Okay, I typed wrongly the password. Here we are. Okay, so this is the academy, and here you have different lessons that the student can have access to them. And as I indicated you, here is for robots, for different subjects like URDF, RBS, controls, etc. And what happens if you access one of those courses? Well, you can just start a course, and then you get loaded with the environment for learning the different lessons. In this case, I have selected ROS in 5 days, ROS Basics. This is for all the subjects that are basic for ROS, like topics, services, action, debugging tools, etc. And you have here all the lessons with the exercises and the results. Here on the center, you have the area where you can create your packages and edit them. These are for very simple examples. And here in the center here beneath, you have the terminals. So I can do, for example, a ROS topic list, and I will see all the topics that are published by this robot here in the simulation. In this case, for this lesson, we are using an ARM robot with a Kinect and a laser on the top. We are using this simulation. And so you can execute your programs here as you want, and then get the result here on the simulation. For example, there is an example here, if I remember, yes, here, that we copy and paste here. This is just a demo, okay? So just to show you that how you can launch a program, and then we'll see the result here in the simulation in real time. So basically, it's the same as a ROS environment, but it's on the web. Here you have a chat line where you can chat with our customer service and ask, of course, questions about ROS. And you can configure this in any way. If we want to use the simulation in a bigger place, or even put it the whole screen, we can do it. And the same for the lessons. So we can go to different places, etc. And we used to use different robots for each subject. In this case, we are doing the ROS services, part 1, that is number 5. If I change to ROS topics, part 1, then the simulation will change, because now we are going to work with the Turtlebot, and we use different robots in different lessons. So that's very, very convenient. At any point in time, you can go back and see the other lessons. As you can see, it is full equipped of different exercises, code, images, etc. And then if there is nothing more, then my presentation is finished and we can go to the questioning part if you want to ask me any question. So I'll be happy to answer them. So just be reminded that there is a small delay between your questions in the chat and myself answering, because there is a little delay in the transmission of the image and the voice. Please, if you have any question, you can put the questions on the chat. Oh, before we go to the questions, sorry, let me just go back to the presentation so I can show you the details for how to get the slides and the white paper with additional information. So in order to get the bonus for attending the conference, just send me an email to this address and with this subject. I want to train my interns fast. And then I will receive this and I will get to you with the white paper and the slides of the presentation. So here I am, ready for your questions. You can put the questions on the chat on the side of the video, of the YouTube video. There is a question here about Anuba Dogra asking about will the recording be available? And the answer is yes. So after this we finish, it will be automatically uploaded to our channel where you can subscribe. I recommend that you subscribe because we are doing there in our channel, we are putting a video every day. Every day we upload a video solving a question about ROS. And it will show you in detail in this video how to solve this question, this subject, so you can receive this. And also we are uploading some webinars, also tutorials about the specific subjects. So if you want to know about our videos, just subscribe and press the bell, because by pressing the bell you will be notified every time that we publish a new video. Pablo Zuniga is asking, is there any free trial in this academy? Yes. If you go to the Robotic Night Academy, that I'm going to put the address here in the chat, academy.com. This is another way of going, okay? I've shown you the way of going through the web page of the company, but here you can go straight. Then there you will see if you create a free account, and then you have a free trial of any of the courses there. The first chapter is for free, and you can practice. You can use the shell. You can create packages. You can do whatever you want, but only for the first lesson of each course. Any other question about the subjects that we have been explaining here, about the method, about the list? Mathieu Loret, he's saying, hi, don't you think that not teaching ROS with C++ will close some doors? Some package libraries are C++ only, some company want C++ only. This is a very good question, Mathieu. Yes, definitely. It closes some doors by the moment. So I don't say that you don't have to teach C++, but what I say is that you have to teach C++ once the person, ROS in C++, once the student, the intern, knows and understands all the subjects about ROS. What is a topic? What is the callback? What is a service? What are the messages, the formats of the messages, the differences between a string of Python and a string message of ROS? So all those things they create a lot of confusion on the students. And if you do that in C++, it's a lot more difficult. It's a lot more difficult because, as you know, the ROS in C++ contains a lot of other subjects like the callback queue or other subjects that are more difficult, like the threads, like the managing of the threads, that in Python is automatic, but in C++ it's you who has to handle. That is too much for a beginner mind. But once this person knows about ROS in Python, then he is able to get this jump into the C++ version very, very quickly, very quickly. And that's what I propose. And of course, in many, many labs, they don't need to teach the C++ version because they don't. If you are going to work for a company, yes, then maybe in the companies, C++ is important. Yes, that's right. It's important when you are working in for product development. In some companies, you are working in research. Then again, I would say C++. Okay, my pleasure, Matthew. Pablo has another question. He says, do any of the courses cover natural language processing? And the question is no, sorry, not yet, not yet. That is a difficult subject to put into a web platform, you know? It's difficult, yes, because language processing, so by using simulations, and it's difficult. Any other question? So I don't know if have you been what do you think about using the gazebo simulations? What about the notebooks? Do you know how to use them? How to create them? And then Frederick asks, is the price 40 euros per person per month in our academy? Yes, that's it. That's the price, 40 euros per person per month. Exactly. Then some other suggestions about the tutorials list. Do you agree with the deconstruction of ROS, for example? I don't know if you do agree. More questions about if you don't have used notebooks before, then I really recommend you to use it because you can integrate code inside the explanation of the text. And then this is very, very convenient. You can actually include some code that is getting information from the simulation, for example, a laser reading. And you get this laser reading, and then you present in real time inside the notebook to the student. That makes connections in the brain of the student like this, very, very fast. Because the brain, what it wants is to get a reward of what he is doing as fast as possible. In order to understand if what he is doing is producing results or is it not. If you have, for example, the C++ question again, if you have to compile your program in order to see the result and it doesn't compile, and you are not an expert in C++, you are putting a lot of time before this student will be able to see the result of his program because he's trying to compile something that is nothing related to ROS. And also his brain will be put apart, aside from the ROS subject. Then that is interfering in the speed of learning. Will this person learn ROS? Yes, definitely yes. I said at the beginning, I learned this way. But we are not talking about that. We are talking about breaking world records. That's what we are talking here. If you don't want to break world records, that's okay. Just go to the wiki. It's the best place. So also I have to say about the wiki of ROS, that was an amazing step at the time that it was done. Because I remember at the beginning, so and you can see also today that most of the projects, in open source projects, they almost don't have any documentation. And at that point, when ROS, the Willow Garage, the creators of ROS, they put those tutorials there. That was an amazing step, a very, very good step. But now we have improved. So we have improved a lot. So, and we need to improve in techniques for learning this faster. And that's what we propose here. Okay, questions? If you don't ask me questions, I mean, I can talk a lot, but at some point in time, you will get bored. I will start talking about the weather. So I don't know, maybe it's because I did a very good presentation and everything was clear. I don't know. Any question there? Still the chat is open. Okay, so I see no more questions, but the spectators are still there. So I don't know what you are waiting for. So somebody else to ask a question? No, it has to be you. It has to be you. Come on. Okay, so if there is no question, then I think we are going to close here today. Just would like to remind you to subscribe to our YouTube channel because of what I mentioned, that we are answering every day a question of ROS in a video, in a short video, 10 minutes video, but shows practically how to solve it step by step, those questions. So please subscribe to our channel and press the bell. If you press the bell, you will be notified when we have it. Okay, so Pablo is asking me. Okay. Oh, sorry. I missed a question from Harshdeep Kanai. Sorry. And then he says about talking about Jupyter Notebook. If I was talking about Jupyter Notebook, yes, that's right. I was talking about Jupyter Notebook. Sorry, Harshdeep, I didn't see your question. And you will see in the white paper that there is more information about that, about the Jupyter Notebook. Okay, so then the question of Pablo is, do you know if there is any IDE like the ones you show us outside the web page? Oh, no. So what you can use is a Qt Creator for developing with ROS. This is the one that I would recommend you to use outside the web page. So in your own computer, you have to install it. And that's very, very powerful and quite nice. I have used it some years. So I recommend you to use that one. And then you connect that with the Jupyter notebooks, Python notebooks, and with the gazebo. What's the name? Let me write it down here for you. It's what I mean is the Qt Creator. It's becoming the standard in ROS development. Many developers use this one. And there are some configuration scripts that you can use for configuring it specifically for ROS. And then Harshdeep says, where will be the white paper available? You have to send me an email in order to get it. So let me just get back to one slide here. And then, yes, here. So you have to send me an email to this address with this subject. I want to train my interns fast, and then you will get the white paper. Okay. Great, guys. It's been a pleasure to have you here, every one of you, and I hope that you make your interns learn a lot and fast. We need very good programmers in ROS in order to improve this robotics world. Okay, we are all in the same boat, and so let's make this big. I wish you the best. Keep in contact with us in case that you have proposals, questions, whatever. We are here for you. We want to make people learn and develop for robots, and we are here for that. So see you in the next webinar, tutorial, or maybe on a robotics conference. Cheers, mates.